Let's go ahead and get started. We're going to be talking about software that isn't GA yet. So this is the cautionary, our stuff may change, and also our demo may break. 2019, what an amazing time to be involved in technology. Really quick, we try to be inclusive in these conferences, so quick show of hands. Do we have any replicants in the house? Anybody? Nobody? Okay. Everybody found parking for their hover cars and their hoverboards, right? No problems there. Well, we do actually have self-lacing shoes. This is a real thing that came to fruition, as long as you didn't brick it with a firmware update. But with all these amazing technologies, all the stuff you just heard in the keynote, you all decided to come to the batch talk. All joking aside, thank you for coming. We really appreciate it. We were just saying, well, the mics were off. I don't think I've ever had a sold out, there's what, one seat back there, room for the batch talk. So really appreciate it. My name is Michael Minella. I'm the co-lead for SpringBatch. I'm a Java champion, author, speaker, curmudgeon at large. You can find me on Twitter at Michael Minella or at Heap, which is what I'll talk about in just a minute. I mentioned I'm an author. We are actually giving away 2 copies of my new book out, now available. Check it out. We'll give these out later at the end of the talk. Wayne, you are not eligible. You should have gotten your free copies already. All joking aside, one of the tech reviewers for the book, Wayne Lund, is in the house. Thank you for coming. I'm also a member of a podcast called Heap. It is a Java pundit podcast, so if you're into podcasts, check it out. It's a bunch of guys hanging out at a bar talking about the latest in the ecosystem. Mahmoud?
Yeah, so hi everyone, and thank you for coming to our session. My name is Mahmoud Ben Hassine, and I'm a software engineer. I work for Pivotal, and I'm the co-lead of SpringBatch, working with Michael closely. I also run a few open source projects that you can find at jez.org. So you can find me on GitHub and also on Twitter, so feel free to reach out.
Don't worry about taking notes or any of that kind of thing. Obviously, we're being recorded, but also everything, the deck, the code, even a sample of the manifest you need to push the code up to Cloud Foundry are all available here. So I'll let everybody take their pictures. 5, 4, 3, 2. I love how the closer I get to 1, more cameras go up. It's like, wait. 2, 1. And we're moving on. It's my personal belief that ask questions when you have them. It's the best time. That way you don't forget them. It's also, the context is there. And I would much rather make sure all of your questions are answered than us talk at you for the next 70 minutes. Yes? Is this going to be very Java specific? Yeah, this is a Spring talk, which actually leads me to the next question. Lay of the land. I'm assuming since this is a SpringOne platform and this is going to be a Spring talk, everybody is to some degree familiar with Spring framework. Is that accurate to some degree? Cool. With that though, how about SpringBatch? Yes, I see some of these. Okay. How about Dataflow? Again, a couple of head nods, a couple of hands up. Micrometer? A lot less head nodding and a lot less hands going up. Okay, that's what we'd expect. Prometheus, Grafana. Okay, so that's probably the situation we expected. Okay, so what are we going to talk about today? We realize that not everybody is familiar with SpringBatch, so we're going to take a couple minutes and kind of level set and do a SpringBatch 101. We're not going to go real deep into a lot of the features. This is really just a boilerplate lingo, and that's about it kind of thing, so that everybody can understand what we're talking about for the rest of the talk. Then we'll get into the day in the life of a batch developer. We'll come in and get our coffee. We'll check the status of the existing jobs running in production. We'll add a new feature, so we'll write a little code. And then we'll push that feature to production. Does that all make sense? Cool. So SpringBatch 101. So what is batch processing? Anybody want to offer a definition? Did you say process a set of junk? I'm asking. I want to make sure I heard you right.
Almost there, but I said junk.
Okay. So process stuff at a set frequency, you said?
Yeah, at a regular frequency.
Okay. What else? Anybody else? Headless? Yep. Anything else? Dumping data? Okay, okay. So the way I like to define batch processing is batch processing is defined as the processing of a finite amount of data, so it's not never ending, without interaction or interruption. So when you think of streaming architectures or web architectures, those kinds of things, you set up an application on a server and it sits there and waits for some type of external stimulus, right? So it's going to wait for a web app's going to wait for a web request. Streaming application is going to wait for a message. Batch doesn't wait for anything. It assumes that everything's there from day one. So when you kick it off, it starts, it runs, and then it shuts back down. Does that make sense? Lingo. So like I said, we're going to cover just some basic terms so everybody's comfortable with this stuff. We're going to talk about jobs. So a job is that finite process from end to end. So that's the thing I'm going to kick off typically at a frequency if you're doing scheduling. But that's the whole process that we're talking about. Now a job can be divided up into one or more steps. Now steps can be executed in sequence or they can be executed in parallel. There's basically a directed graph of how you define those are. But those are essentially the self-contained unit of work that you would have your batch job execute. There are two main types of steps. One is a tasklet step and one is a chunk-based step. A tasklet step is there's actually an interface in SpringBatch called a tasklet. And basically you implement the execute method and we will execute that within the scope of a transaction. It's basically the big bucket of whatever you want us to run in the scope of a transaction. That's what you use. The other one is a chunk-based step. So here we're talking about processing items. We're talking about doing the same thing in a loop, right? So I've got 1 million database records that I need to process. I've got a file with 1 million records in there. So it's that looping over a large collection of data. That's what the chunk-based one is used for. In a chunk-based step, we talk about items versus chunks. So an item is that individual record. So think of a database, it's the individual record. File might be an individual line in a file. And then within SpringBatch, those are grouped together into chunks. So a chunk is a grouping of those that are processed in a single transaction. Let's say you've got 1 million records you want to process. You probably don't want to process all those in a single transaction. So SpringBatch will break those up into chunks and process each one into its own transaction, keeping track of where it's at as it goes. So let's say you execute 5 transactions and then it fails, we can restart at that spot again. Does that make sense? So if we look at kind of, this is what a 3-stepped job might look like. So we've got 3 steps, step 1, step 2, step 3. Each one has an item reader, an item processor, an item writer. So these are all chunk-based steps. So the way this would work is step 1 starts, the item reader would provide the input, the item processor would do any type of transformation, and the item writer would provide the output. Step 1 starts, executes, and finishes. Then step 2 starts, executes, and finishes. Then step 3 starts, executes, and finishes. You can configure these to run in parallel and all that kind of thing, but this is like just a simple flow. Within one of these steps, the sequencing looks kind of like this. You've got the step, which is kind of the driver for a chunk-based step. Then you've got a reader, processor, and writer. For the record, the processor is optional. So reader and writer are the only two that are required in a chunk-based step. So the step will call the item reader's read method until the chunk limit is hit. So if you've got your commit level set to 100 items, it's going to call read 100 times or until null is returned. It's going to take that collection of items and then it's going to loop over those with the item processor. Again, calling once per item. It's going to take all of the output from the item processor and in a single call to write on the item writer, pass them all in a single shot. We do that because there are optimizations on the write side that you can make that are a little harder to do in the reader and the processor level when you're honoring things like skip and retry and other error conditions. Does that make sense? Cool. When we talk about all these components and how they all fit together, so to start a job, you need a job launcher. So that knows how to run a SpringBatch job. That's going to talk to the job repository. All SpringBatch jobs are stateful, meaning that we keep track of what job is run, with what parameters, what step has been run, how many transactions have been run, how many items are read, all those kinds of things. That allows us to handle skip, retry, restart, all those kinds of things in a robust way. So the job launcher is going to report to the job repository, I'm starting job X with parameters Y. The job is going to report back to the job repository, I'm executing step X or step Y. The step is going to report to the job repository. I'm on chunk 1, chunk 2, chunk 10, and so forth. Does that make sense? So, any questions on SpringBatch before we dig into the more interesting stuff? Yeah.
So the repository, is it like what? Is it a RDBMS? Is it configurable? What are the ways?
Yep, good question. So the question was, what is the job repository? It is a relational data store. So most of your traditional relational databases are the ones we support. We also do have technically an in-memory one. It's a bunch of maps. It's useful for testing, but we in no way recommend it for any type of production use. Yeah.
Can we go back to the slash the reader, processor, and the writer?
This one?
Yeah.
Yep.
So does the reader and the process, those two can run in parallel, or the process is after reading?
Good question. So the question was, can the reader and processor run in parallel? No, they cannot. What you can do is actually the opposite, which is the processor and writer. You can do those in parallel. Well, actually, I take it back. You can do the processor and writer in parallel. You can also do all of them in parallel by chunk. So I do a whole nother talk on scaling this stuff. So I'm going to defer to that talk. It is available on YouTube. Or I can answer more detailed questions afterwards. But yeah. Anything else before we move off of just SpringBatch 101 stuff? All good questions. Cool. So I mentioned we're going to check the status of some existing jobs in production. So we've got some stuff running right now. Let me lay out kind of a lay of the land of what's currently running. So we've got a batch/task application running. This is running on Cloud Foundry. So it's getting kicked off once a minute by Cloud Foundry scheduler. And so it's going to report its status to the relational database. We're using MySQL on Cloud Foundry. We also have Spring Cloud Dataflow running. So Dataflow, we are going to use that to deploy applications as well as monitor our SpringBatch applications to determine, are they running correctly? Are we getting the outputs we expect? Are they, all that kind of stuff. And I'll give you a tour in just a minute. While SpringBatch is running, we also want to get more granular metrics. So things like how the JVM is doing, thread count, throughput, those kinds of things. And we're using Prometheus for a metric store, but there's a problem there. If you're familiar with Prometheus, you know it's a pull-based model for fetching metrics. So Prometheus calls your app to get them. What's the problem in that scenario with a batch app? Pardon? Exactly. You don't know if the batch job's running or not. So it may not actually be there when Prometheus asks for the metrics. That's what that RSocket proxy is. So this is a project out of the Micrometer ecosystem that basically allows SpringBatch, when it's running, to make an RSocket connection to that proxy and report metrics to it in a push model. Then Prometheus will actually scrape the proxy instead. The proxy keeps the metrics in memory just until the next scrape, then it flushes them. This allows SpringBatch to provide the metrics when it's running, as well as there's also a shutdown hook that when it shuts down, it'll flush at the end. But this allows this intermittent execution model to work with a Prometheus as a store. And then we're using Grafana for our visualizations ongoing. Does this all make sense before we actually dive into looking at the tour? Cool. So let's go ahead and actually look at what's running. So I'll bounce over here. So this is Spring Cloud Dataflow. So I have a single app registered. So the way Dataflow works is, in order for it to run an app, you have to register it. So that tells Dataflow the kind of app it is and basically where the bits are that it needs to run. So basically where the jar file or Docker container is to run. So in this case, I've got a single app. It's called S1P Austin Job. It's of type task. That's what your batch jobs will be. And this URI is just the Maven coordinates for finding those bits. And you can see I only have one version registered right now. We'll take a look at when multiple versions are involved in a minute. So once my app is registered, now I want to run it. So I need to create a task definition. The definition is a combination of that app that we'd registered, as well as any properties or configuration that we need to provide to make that work. In this case, I don't need any. That's all provided by the platform. So the graph itself is literally just that. It's just the box. There's nothing else there. And then we have this application currently scheduled. So we have one schedule. This is the schedule. It's running this. That's the task name, and then this, you can see it's running once a minute. And so if we bounce over to here, the executions, these are all the executions that have been running basically since we got on stage. So you can see we've got all these different executions. If I grab in, let's refresh. So this one just finished. We can take a look at this one. And so you can see I've got an execution ID, task name. These are the arguments that I passed in, command line args. This external execution ID, will reference back to the platform itself. So if I go to Cloud Foundry and say I want to look at the logs for this task, I use that ID. It identified that it is a batch job. We'll get to that in a minute, and as well as the reference there. It's got start time, end time, how long it took, exit code of 0. That's the process exit code, as well as the logs. And so you can see here, our batch job is really complex. We're reading out a random number of numbers and kicking them out to system.out. Complex stuff here. And then, so that's all at a task level. So, but for SpringBatch, we can go into the job executions. And so now we've got the job name, job instance ID, and we can see the duration. It was completed successfully. The exit message, there wasn't one. There was one step. It had 8 reads, 8 writes within 3 transactions. And then you can even dig down even further here. So we see all the filter count, process count, and so forth. Does this all make sense? So this is all what Dataflow provides from a metrics perspective here. This is all traditional SpringBatch. This is all being read from the relational data store, the job repository. But I mentioned earlier that we are also publishing metrics to Prometheus. So let's bounce over to Grafana, and we can take a look here. And so you can see here at the top, we've got, these are the traditional metrics that Spring Boot is providing with Actuator. So Heap, non-Heap, all that kind of stuff. And then down here, you can see these are the durations. We've got this at a 5-minute interval, so that's why you don't have a ton of them. But so you can see, the duration of the jobs, the throughput input, the read throughput and the out throughput. The reason these are as low as they are is because we've got a thread.sleep in there to slow it down, just for illustration purposes. And so everything here is out of the box. So you don't have to, you as a developer don't have to write any code to get anything that you've seen. Does it all make sense? Yeah.
So is there like specific batch metrics that do all that stuff?
Yeah, so the question was, are there specific batch metrics that does this stuff? And yeah, so these bottom 3 boxes are specific to SpringBatch. Those by including by upgrading to SpringBatch 4.2, you'll get this stuff out of the box. And then there's a couple other ones that are in their documentation, or Mahmoud can speak to later on when we talk about the new features in 4.2. Cool. So that's kind of the state of the state right now. Everything seems to be running. It's in production. Everything seems to be running as expected. No jobs are failing. Metrics all look good. So let's go ahead and write a new feature.
All right. Thank you, Michael. So as Michael described, we have a job with a single step now, reading and writing some random number of items. And the idea is to add a new step to the job and then deploy it to Spring Cloud Dataflow. So let me go ahead. So the first thing I want to show you is the implementation of the current job we have in Spring Cloud Dataflow. So this is the job configuration. So it's a configuration class annotated with enable batch processing. So this annotation will add the infrastructure beans that SpringBatch requires, like the job launcher, job repository, and so on. One of these two are, by the way, the job builder factory and step builder factory. Those allow me to create jobs and steps. So here is the job. It's a simple one with a single step, which is defined here. And this step is a chunk-oriented step, so with an item reader and writer with a chunk size of 3. So each 3 items will be read, processed, and written in a single transaction. So the reader is this one. It's a list item reader, so it will read a random number of items each run. And the writer is also very simple. It will go through the items, sleep for a random period, and then print out each item. So here I have a random failure, just to illustrate failures so that we can see them in the dashboard here. So sometimes you will see that the write failed. So this is just for illustration purpose. Okay, so the idea of the new feature is to add a new step. As I said, it's a tasklet, and to keep it simple, just since we are reading a random number of items, let's say we want to show the read count in the logs. So the number of items that were read in the step. So let me go ahead and create a new step. So I will rename this one as step 1 and then add the next step. Call it step 2. Copy paste is the best invention. Step 2. All right, so as I said, it will be a tasklet step, so I can do tasklet and create a new tasklet here. All right. So now what I want to do is to take the read count from step 1 and pass it to step 2. So I need to pass the information from step 1 to step 2, and the information is the read count. I can get it from the step execution. I will show it later. But how do we do that? Well, we can do what all great programmers do. Go to Stack Overflow and grab some code. We don't have time to read the SpringBatch documentation. So SpringBatch, pass data. Yeah, this is how it works in real life. Between steps. All right. Oh, good. Looks like someone already asked the same question with an answer, accepted answer. So that's great. Okay, so it looks like we need a listener, step execution listener, and we have some code here. So let's copy paste. Yeah, really. Okay, so it looks like we need a listener. So I'm go ahead and add a new step execution listener. Okay, paste the code, change it.
This is a Josh launcher.
So you copy paste and you change it until it compiles, and then you ship it. So basically, we have a listener. So the idea is to have a step execution listener. So this one will run after the step, and normally after the whole step is run, we have the read count. So I can get the read count. So let me add some formatting here. So it looks like in Stack Overflow, we put a string in the job execution context, and it looks like this is how we share information between steps. So we take the information, we put it in the job execution context, which is global to the whole job. So here we need the read count. So let me get from the step execution, get read count, okay. Of course, it's an int, so I have surely an int here, cool. And then the key should be read count. Okay. Now I don't want to return null, so I can return the super method here after step with the same parameter. Okay, looks good to me. After the execution, I take the read count and I put it in the job execution context under this key. Now I think the other way around, if I want to read it, I think it should be the same. So let me do it here. And instead of put, I should get. It should work. Okay, so now I need a step execution. Where can I get this? Probably from the chunk context. Let's see. This is how it works. Huh? Get step execution, cool. Now it compiles. Maybe I can here in return finish. So I finished. I get the information. I would like to put it in a variable. So let's go ahead and put it in a variable. I think I can do something like get int. Yeah, I don't want objects. This is better. And then I can print the read count. Okay. We use lambdas. Those are better. Okay, so looks good. The first step will put the info in the job execution context. Then the second step will read it from there and print it to the console. So let me go ahead and try to run this to see if this works. So remember, step 2 might fail here randomly in the writer. But if it succeeds, we need to get the read count in the second step. Yeah, looks good. That's Stack Overflow driven development. So we have the read count here. Now my feature is implemented, so let me go ahead and push it. add feature X. Okay, that's fine. Push. And push it to GitHub. All right. So now my code is pushed to GitHub. It should be. It should take some time now to kick in the CI/CD process. So in the meantime, I'm going to take the opportunity to present you the new features in SpringBatch for the 2.
You want to walk through what the mechanism is, that the CI/CD mechanism?
Yeah, we are going. I'm going to explain this the whole process so that we have an idea. So our code is hosted on GitHub. So I just pushed the code in a branch actually, and what will happen is that we have a CI/CD job at Circle CI, so which is a CI/CD platform. Which will kick in and then push the artifact that it built to Maven repository, and also notifies Spring Cloud Dataflow that there is a new version of the artifact. However, in this demo, so Spring Cloud Dataflow will check Maven repository for the new artifact in the next run. So remember, we have a schedule for each minute. So when the CI/CD job on Circle CI notifies Spring Cloud Dataflow with the new version, Spring Cloud Dataflow will grab it from Maven repository. But in this demo, we are going to use another service called jetpack.io, which will actually build the artifact on demand. So you give it a hash and it will build it for you, which is nice for demos, but it's not recommended for production. So here, when the Circle CI job will tell Dataflow, look, there is a new version, here is the hash. So when Spring Cloud Dataflow will ask Jetpack for this artifact, it will build it on the fly and give it to Spring Cloud Dataflow. So does this make sense? Any questions on the CI/CD pipeline? So normally what we expect to have is like in the next run, we have the changes pushed, and the next execution should show the read count in the console. So let me check if we have it already. Otherwise, I will show you the features. So if you go to tasks here, executions, yeah. So you see here we are waiting for the deployment of the new artifact in Spring Cloud Dataflow. So this should take a few minutes. So let me go ahead and proceed with the presentation. Yeah. So SpringBatch for the 2 went GA last week, and as usual we have new features, performance improvement, and bug fixes. So we wanted to share some of the new major changes in this session. So in terms of new feature, we have batch metrics via micrometer. So this is what Michael showed, and we have them without any code change actually. So it's right in the framework. You upgrade to SpringBatch for the 2. You just need to know that we have now a new jar that you must have in the class path, which is a micrometer core, and then it's up to you to choose the client library. So in this demo we use Prometheus, so we have a second jar for the Prometheus client, but you can use InfluxDB or any other metric store supported by micrometer.
Yeah, really quick, for those of you who are unfamiliar with micrometer, micrometer is kind of like SLF for J, but for metrics. So it's an abstraction where you can write dimensional metrics, and then you provide whatever implementation you want, Datadog, Prometheus, etc., and it will publish it based on whatever's on the class path.
Exactly. And even better, if you use Spring Boot, it's automatically configured, so you don't have to do anything. However, if you don't use Spring Boot, you have to configure the client yourself. Another interesting feature we added is the support for Apache Kafka. So this is really interesting. So we now have a new item reader and writer to read and write data from Kafka topics. What's interesting is that the reader complies to the SpringBatch mechanic, so it's stateful, which means that it stores the offset of each partition in the execution context. So if it happens and the job fails, when you restart the job, it will read from the last known offset and not from the beginning. So this is really cool. A second property is that it supports multiple partitions. So if you have a partition topic, you can read from multiple partitions. That's really cool. And this is actually a very cool feature, really awesome, because it opens up a whole new world of use cases, like, for example, writing jobs that act as a bridge between the streaming world and the batch processing world. I can imagine, like, I have some static data in a file or a database. I can inject them in a live stream, or the other way around. I have a live stream of data. I can dump it in a file or a database table and then replay it afterwards. So this is really awesome. Probably related to this one, but not necessarily. We added support for Apache Avro data format, which is widely used in the Kafka world, I think, Apache Avro. So we have a new item reader and writer for Avro files, which support also the embedded schema or not embedded and so on. So really cool addition here, which goes with the previous one. So that's it in terms of features, the major ones. We wanted also to show you some of the performance items we have been working on in this release. The first one is related to step partitioning. So you might probably know how step partitioning works in SpringBatch. So basically, when you run a partition step, and let's imagine it fails, when you restart it, you just run the failed partitions. You don't restart all of them, so only the failed ones, which makes sense. However, when you start a partition step, you have to check if the last execution was successful or a failure. So this check was not really optimized up until now. So we worked on this process and we tried to optimize it by using SQL query, actually. So it was loading all the step executions and doing the filtering on the application side. Now we are doing it via a single SQL query, and it's a lot better. So we have up to 10 times faster step partitioning with this approach. We added a link to the benchmark at the bottom, so you can go ahead. You have the detailed instructions there. You can replay them and see, because it depends on the use case, the number of partitions, and so on. So this is the first enhancement we wanted to show you. The second one is about the job stop. So you might have been in this situation where you start a job and you realize you passed in the wrong parameters and you start seeing your data corrupted and so on. All you want is to stop the job as quickly as possible, but you don't want to kill it with kill-9, so it's not the way to go. So we want to stop it gracefully via an API provided by SpringBatch, like the command line job runner. So stopping a job was loading all the job executions in memory to find out which one it is currently executing to stop it. And this was not really optimized, so it's similar to the other one. We replaced the code by a SQL query that does a single interaction and grabs the last execution. And this is significantly better. So it's up to 40 times, I guess, faster to stop a job now with SpringBatch for the 2. Yeah, the link to the benchmark also in the slide. And the third major improvement concerned the JPA item writer. So here, it's actually when you use the writer in a file ingestion job, for example, and you want to map your records to JPA entities. So you can use this writer for that. The only issue with that is that it uses the merge method of the entity manager API, and this merge method actually does a check to see if the current item is in the persistent context. If it is, so it will merge it. Otherwise, it will create a new persistent entity. And this check is actually costly, expensive when you know that your data is new. So when I have new records, I know those don't exist in my database, I can use the persist method instead of the merge method. And if I use the persist method, it's twice faster. So the new feature is actually a flag that tells this writer to use the persist method when I know that my data is new. That's it. Let me check before going this slide if we have the new batch job deployed to the Spring Cloud Dataflow server. Okay, so I think it looks like the batch, the new version is deployed and already run a couple of times. So let's see if we have the change in the logs. Yeah, so it's in here. This means that my new version has been correctly built and grabbed by Spring Cloud Dataflow, and now it's running in production in the next run. And this closes up the whole CICD process. Cool. So another important change we wanted to mention in this session is the replacement of master and slave terminology. We don't use them anymore. Those can be offending, so we prefer to not use them. So we replaced all APIs containing master and slave with actually a manager and worker. So
yeah, to be clear, everything is deprecated. We'll actually pull it out in a future version, but it's all, the master slave ones are deprecated. They're new functionally equivalent versions of the stuff with the new nomenclature.
Exactly. So to make it backward compatible, we deprecate the current APIs. We add the new ones, and then we remove the deprecated ones in the major version. And we did this, of course, on the API level, the XSD level, and the documentation. Yeah.
Cool. So Spring Cloud Dataflow 2.3, that's the version that's currently in development. 2.3 M1 came out, I believe, last week. Glenn, call me out if I'm wrong. I know you're back there. I'm right. All right, cool. So new features in Spring Cloud Dataflow. First one is continuous deployment for tasks. That's what this demo is about. Let me show you a couple nuances with regards to how this works. So if we go to Dataflow, it's really fundamentally comes down to this page right here. So if I refresh it, you can see there's a 2 here now. And so I actually have 2 versions of the app registered. So what happened during that CI push is it registered a new version. So it said, hey, there's a new version. And in this case, using that Jetpack IO, the version number is indicated by the hash of the commit. So if you take that, go to GitHub, that's what it's pointing to. So it registered the new version, and then it changed the default. So you can register as many versions as you want, but Dataflow is going to keep using the version that's the default until you flip that. So that's really the deploy switch, if you will. So the CI pipeline piece, what that did is it registered the new version and then changed the default to be that new version. And then what happened is Dataflow then, on the next run, said, oh, I've got a new default. Let me delete the old one on Cloud Foundry and redeploy a new one. The other thing that I should note on here is, if you go back to the executions, where's it? You'll notice a little gap here where we've got a couple NAs. The reason for that is the build process, the push process, that takes time. And so to prevent there to be essentially a race condition, Spring Cloud Dataflow, when a new deployment is required, any future requests to deploy that app or to execute that app are basically canceled until the deployment's done. Once we finish this feature and push it out to GA, we will have a force flag in there so you can come in with your sledgehammer and overwrite everything. But for safety purposes, obviously, we wouldn't want you to kill running jobs is basically the big concern. Yeah.
Is there any other reason why you might get an NA?
Good question. The question was, is there any other reason you'd get an NA? So the way Dataflow works with tasks is when you launch a task, it creates this record in the task repository. All it's going to have is an ID and a name. The NAs here indicate that the task wasn't actually started. So basically, this indicates that a request to Dataflow was made to launch a task, but it didn't actually happen.
Are there plans to make that more intentional in this case, where instead of NA it says deferred because of build or something like that, so that the operator knows what's going on?
Excellent idea, and there's no reason for us not to. We've got the information. So yeah, we'll yeah. You have your laptop in front of you, Glenn.
Look at your issues on Spring Cloud Dataflow, you'll see it.
Thank you, Glenn.
You're welcome.
So, yeah.
Are these configured as tasks in PCF?
Yes. So the question was, are these running as tasks in PCF? Yes, they are. Yes. Yeah. So, which is the benefit of doing this kind of work on Cloud Foundry is, so for those of you who aren't familiar with running tasks on Cloud Foundry, a task is a finite process. So you launch it, it runs, it shuts back down. So if you're currently running your batch applications, let's say in an app server somewhere, you got this process that's sitting there probably all day, probably not actually doing anything most of the day. I see heads nodding. So the idea of Cloud Foundry running these as tasks is you're only taking up resources when they're running. So when the schedule kicks off, it launches, runs, and shuts back down, freeing up those resources for you to run other things at the rest of the day. Yeah.
What's the difference in this case what's the display between a task and a job? I know that jobs are batch jobs.
Good question. So what's the difference between what's on the task screen and what's on the batch screen? Spring Cloud Task is a project that was intended to bring a lot of non-functional features to running this type of workload in the cloud. So when we created Spring Cloud Task, things like start time, end time, exit code, if an exception happened, what caused it, those kinds of things weren't common on cloud platforms, and frankly, they're still not in most cases. So we created this project to give you a generic way of handling that across all platforms. So a lot of this stuff comes from SpringBatch. The idea of a repository, the idea of the start time, end time, capturing the exceptions, all those kinds of things come directly from SpringBatch. So you might almost think of it as a simplified version of SpringBatch, because theoretically you could write just a single-step batch job with a tasklet, and you'd get 80 or 90% of the features from Spring Cloud Task. But you've got also additional weight, if you will, from SpringBatch that you really don't need. So does that answer the question?
More interesting, what's the difference in what's displayed?
Oh, like literally what's displayed?
What would I need to go to jobs versus?
So jobs are going to have the job specific stuff. So there's going to be a step execution count. There's an actual status with SpringBatch. So in this case, you can see we had a job fail. If we go into the job tab, you can see, okay, so this was that random exception that Mahmoud had mentioned. So you can see this kind of stuff in here. You can see, if you had a 10-step job, at the bottom here, you would see all 10 steps listed out in reads, writes, and all that kind of stuff. Does that answer the question?
Yeah.
Cool. There's another one for, yeah.
What's the retention and configuration? Date range or number of executions?
Good question. So the question was, what is the retention policy for basically these records? It's infinite. But with that, Spring Cloud Dataflow 2.2, I believe, was when this was added. We gave you the ability to clean this stuff up. So I can go in, and actually I can do it right now. Demoing without testing. This will go well. So we can do this, and I'll keep the last one. So clean up task executions. Clean up. And so you can see now, like, the 30 that were on the page are gone. So, and you can obviously script that and do whatever you need to run that as well. Yeah.
One more.
Yep.
What is the end-to-end configuration of a batch job on Dataflow and PCF? Like, if you deploy on Dataflow, is there any way it can be integrated directly for deployment on PCF, or there are two separate work streams where I deploy on PCF as well as configure on Dataflow?
I'm not sure I follow.
Never mind, I'll discuss later.
Okay, perfect. Other questions? Yeah, in the back.
What is the difference? How did the task that has been discovered from Dataflow when you push the artifact there?
So yeah, good question. So the question is, how did Dataflow know about the task, the new version, right?
I might have like 5 tasks in the artifact.
Yep. So if we go to Circle CI, you can see I actually make 2 curl calls. So Dataflow, for those of you who are unfamiliar with it, Dataflow is a server, the pieces that you interact with. You've got the server piece that's running in Cloud Foundry right now. There's the UI, which we've been looking at. There's an interactive shell that you can use. And both of those sit on top of a RESTful API that you can consume directly. So in this case, I'm consuming that RESTful API directly, literally doing a post of the new URL for the new version. That's the first step. And then the second step is that registers the new version. And then the next one, where's it at? Yeah, this put changes the default for me. So that's how Dataflow found out that there was a new version. So when we did the git push, this encircle CI ran, and that these curl commands were executed, calling back to Dataflow, letting Dataflow know that those are there.
But the task is say the task is run this job every day at 10 o'clock.
Yep.
Where is this defined? In the artifact itself or in the
The schedule piece.
yeah.
So where is the schedule piece? So this task has a schedule. So we actually schedule task. Yeah. So here. Oh no, sorry. It's going to create a schedule. I don't want to do that. So here. So this is the actual schedule here. So this is going to say. This is demoing live. And the guy who wrote this is telling me don't look at it right now. But this is where I set up the schedule. I set up the name of the schedule to create, what task to run. So if I can do that. I'm not actually going to do it, but if I do the schedule task, so I provide a name for the schedule, the cron expression, and then this is the task name. This is what to run when that schedule kicks off.
Can you create dependency between jobs?
So the question is, can you create dependencies between jobs? Yes, so that's in the task definition. So that's what we call a composed task. So if I were to create a new one, so I could do, let's say I've got 3 of these. I could go from start to 1, 1 to 2, 2 to 3, and 3 to end, and blow that up a little bit. And so that will execute 1, then 2, then 3. And so if you had, obviously you wouldn't do the same thing 3 times, and you can do this in parallel. So I could do, I could execute 1, and then I could go, oops. There we go. And then back down to, oops.
So actually, Dataflow uses SpringBatch custom to drive this.
Yeah, so that's a good question. So SpringBatch is actually what's used to drive this directed graph. Yes. So this would execute the first one, then these next 2 in parallel, for an example. Yeah. So. Can we make so the question was, can we make these configurations as code? They are I didn't show it, or I wouldn't pay attention to it. Where is it at? Create task. So as I'm doing this, dragging and dropping in a UI, which almost no developer actually does, except for people like us on stage, you'll notice that there's this thing going on here at the top. So if I did, 2 of these, let's say. So this is the piece that's actually code, if you will. So if I cut that out, if I paste it in, it'll automatically update. So it would be if I didn't have, if it wasn't a duplicate. This is technically invalid because I don't have a label. But so you can copy and paste that in, and getting to that, I'll use that as a segue to the other features here. So we talked a bit about, we also have micrometer metrics for SpringBatch. We've also added them for Spring Cloud Task, as well as in Dataflow, the integration to those. So if you click on the Grafana link in Dataflow, it'll take you directly to the dashboard. And then the last piece that you were asking about is import-export. So while we don't have this as code, as in like you write Java code and do it, we do have the ability to import and export those DSLs, the text base at the top. So you click a button, it'll export it for you into a file, and then you can check that in, move it around, all that kind of stuff. Does that make sense?
And this one is actually important. Sorry, Michael. Yeah. So when you write this text, you can use it from the UI and also from the shell, because as Michael said, there is a shell application. So you can type in your compose task with the ampersand and so on, and it will accept it. And it will just talk to the server through the API. So we can script actually creating task and compose task and so on.
Cool. With that, any additional questions before we get to the reason everybody came, which is to give away books? Front.
Can you go back to your data flow webpage?
Yep. Oops.
So how do you pass different configurations for the jobs?
Good question. So my job is stupid. It doesn't require parameters. But if it did, it's literally as if you were typing it at a command line. So it's pipes and filters. So foo equals bar, etc.
If you have multiple jobs.
So if you have so let's say if we did, and this is where my expertise on the DSL starts to fall apart. I don't remember the syntax for labels.
Put a go in front of the S1P,
Is something colon?
ABC colon.
All right, cool. So now it's valid, and so now I can actually do this,
Yeah, put an ABC.
and that actually works as well. But now, so like if I want to do, so foo bar is for the first one, and High Austin is the second one. Does that make sense? In the back.
Yeah, you talked about the Kafka integration.
Yep.
Does the Java repository store in Kafka?
Good. Good question. So we did talk about this. It does not currently. It's something that we'd want more discussion about it. If there was a strong push from the community, log an issue and we can have some discussion about it. Sorry, the question was do we support the job repository being stored in Kafka? And so we talked.
Yeah, what happens if we integrate with Kafka? We have like a reader and a writer that way.
Yep.
The jobs fail to connect to the database to save the job status.
Yep.
Handle that.
So the question was if you can't get to the job, the repository, what happens? And SpringBatch will fail there regardless of like that's not gonna you'll restart at the last known state, right? So, but that's an issue. I mean, yeah, it's exactly yeah.
This
like
is
I
a
said-
generic problem. Yeah, go ahead,
Yeah.
Michael.
If we have concrete interest from the community, like go ahead and log an issue, and we can talk about it and work through it. But like I said, we talked about this, so I fully expected this to come up. Yeah.
So this is, just to add some information. So when you use multiple data sources, like a database for a job repository, and you want to write data in another database, so you have this problem of synchronizing the business data and the metadata. So usually what you have is a JTA transaction manager to coordinate it's the XA protocol. And it's not different from using a database and a GMS queue or a Kafka stream or something. You have to synchronize them. By the way, when you use Kafka, you need to use the Kafka transaction manager with your item writer. And then if you want to synchronize, you have to use the XA protocol, which is quite complex. So yeah, using Kafka as a job repository, it was a discussion. But yeah, if we open an issue, a feature request, and we will see.
There's one back here first.
It's somewhat related to the Kafka question. Will the item reader and writer conform to any schema registry you have defined in Kafka distributor or?
Another thing we talked about.
Can you repeat the question, please?
Will the item reader
Schema
and
registry.
writer conform to schema registry definition in Kafka?
Is this related to Kafka or to Avro?
Oh, yeah, actually, I have.
You mean Avro, right? Yeah, so basically, so the question is, does the reader and writer conform to the schema of the written and read data, right? So for Avro,
Wait, does it conform to that, or does it use an external schema registry? Yeah.
So for Apache Avro, you can, it's not supported for now, but you can embed the schema in the file and read it. Otherwise, you can provide it as a separate schema. So both of them are. But the schema registry, for the first step, I think it's not really supported.
Yeah, not yet. It's something we talked about, and it's definitely something. Again, open up an issue. It's definitely something that's on our radar, and we'd be more than happy to.
Exactly. Yeah.
It's one of those things that makes sense. So,
Yeah, I have a question on the Kafka. As we know, Kafka is stateful and the SpringBatch is stateful. Let's say I have a job and I read from data from Kafka and then somehow the job failed. Which way I should go with when I restart it? The state from Kafka or the state from SpringBatch?
So the question is related to reading from Kafka, and when the job fails, do we read the state from the metadata of SpringBatch or the metadata of Kafka?
Correct.
Okay, so the answer is we will read the state from the SpringBatch metadata repository, because the reader, when it goes, it will save the last known offset in the job repository, and this is how SpringBatch works for all other readers. It will start with loading the execution context, and this is where it will read the last known good offset. So it will read from that offset.
it's actually one of the advantages of Kafka because we don't have to worry about getting messages back on the queue if from a transaction if it fails. Usually, most message middleware, the transaction is for a single item, whereas in batch we're processing multiple items. We've got some workarounds within SpringBatch so we can do that with JMS and whatnot, but Kafka makes it actually pretty easy because all we need to keep track of is the offset we consider it as a good one, and we can restart there and go back.
Exactly. And this is also for multiple partitions, because if you read from multiple partitions, you can be on offset 1 in one partition and another offset in another partition. So we store all of them, and then we start from the last known points. Okay.
Anything else? Yep, back corner.
Do you have any item reader for, say, reactive process?
So the question was, do we have any readers for reactive stuff? And so if you're interested in that, talk to me is basically my answer to that. We've been talking about it internally for a long time now, basically as long as Project Reactor's been around. And that's something specific that we really want to work with somebody in the community around a real use case for. So if you have a real use case that we can work with you on, talk to us. We'd love to actually work on it. We've got some ideas. We really couldn't even address it up until Spring Framework 5.4 that just came out anyways, because in order to honor the contracts that SpringBatch does around transactionality, there was no transaction support for reactive workloads. So we didn't want to basically say, we'll create a reactive step and dump all the other stuff you expect from SpringBatch. So now that we have that capability, it is something we actually would like to explore. But I think we'd like a real world use case so we can actually, we don't want to just be like, slap Reactor on this and it'll make it better, because we know that isn't the case. Yeah.
So one of the things that we see when we are operating these data flows is that we'll see that just the Austin job just keeps showing over and over and over.
Yep.
But is it possible for us to do anything that will make the parameters that are passed show up in that task name column so that you can kind of quickly glance and see what was different in 2 months?
Open a request. Yeah, open a feature request.
The Grafana integration that's there on the screen, is that something that has to be configured manually, or is that something that's picked up automatically through the selection of your specific plan?
So with the question was, is the Grafana dashboard button up there, is that something you have to configure explicitly? You do have to configure Dataflow, basically where is Grafana. So in my manifest for Cloud Foundry, there is the URL for the Grafana server. Anything else before we get to books? Going once, going twice. All right, we've got 2 books to give away. You're gonna have to earn them, so you have to answer a question. So we've got one question that's pop culture-ish, and another one we're gonna do that's actually batch related. So for the first one, we'll do the pop culture one, unless you object. Cool. So. Huh? Oh, thank you. So the first one. The first joke we had today was about the replicant thing. What does that have to do with this talk? What about it? You're right on Blade Runner, but there's a different.
Job running versus blade running?
Nope. What else? I'll give you a hint. Think about the title of the talk. What about 2019? Exactly, yes. Blade Runner takes place in 2019. It's the only year I could actually get away with this talk, with that joke. You can give away this one. It's your question.
So the second question is, can you remember how did I share the data between step 1 and step 2?
You went on check exchange, copy the code,
So
and
going to
refactor the code and
The job context.
job context. Basically, you entered the data into job.
Yeah, so it's through the job execution context. So congrats. Going to Stack Overflow was just the
That's all we had, ladies and gentlemen. Thank you for coming. Enjoy the rest of the conference.